Today we're going to talk about section 13.3, trigonometric functions of general angles. Basically we're going to put together trig, the coordinate plane and your angles. So let's say I have a coordinate plane right here. Now if you remember right, we have sine, cosine, tangent, cosecant, secant, and cotangent. We're going to use those in reference to our coordinate plane. Let's say I have a terminal side right there. So I've got a theta. Now theta is like an unknown or an x for an angle, so it's just another way to say it. I'm going to drop a straight line down right here so that I form a right triangle. Well, the distance over here is going to be my x. My distance up is going to be my y. And then I'm going to call my hypotenuse r. Now, you remember Pythagorean theorem, so r is going to equal the square root of x squared plus y squared. This squared plus this squared equals that squared. So I've already got that point. But I also can do my trig functions here. So remember, sine is opposite over hypotenuse. So the sine of theta is equal to y over r. The cosine of theta is adjacent over hypotenuse, or x over r. Tangent of theta is opposite over adjacent, so y over x. Then I'm going to move on to cosecant. The cosecant of theta, remember, is the inverse of that, so it's r over y. The secant of theta is r over x, and the cotangent of theta is x over y. So that is our trig functions on a coordinate plane. Let's do a problem that has to do with those, and I'm going to leave this right here so that it'll help you. Let's say they want to know the sine, cosine, and tangent of theta when the terminal side passes through 8, negative 15, okay? So I'm going to put 8, negative 15 on my coordinate plane. Okay, approximately right there. So, okay, I'm talking about that angle. But I am always going to draw my right triangle. I'm always going to form it with my x-axis. I'm always going to drop, or in this case, I'm going to raise a perpendicular line from my angle. So there's my right side. Now understand, if I've gone over 8, this is 8, I've gone down 15, so this is negative 15. I can find my r value by doing Pythagorean theorem. So 8 squared plus negative 15 squared is going to equal r squared. So when I do that out, I find that r is going to equal 17, because when I put those two together, it's going to be the square root of 289. The square root of 289 is 17. Now, r is always going to be positive, so the hypotenuse is always going to be positive no matter where it is on the coordinate plane. So now I'm going to do my 6 trig functions based on this triangle. I'm standing right there where theta is, so my sine is opposite, which is negative 15, over 17. My cosecant is going to be just the reverse of that. I forgot to put theta in there. 17 over negative 15. My cosine is going to be adjacent over hypotenuse, or 8 over 17. So my secant of theta is going to be 17 over 8. My tangent of theta, remember I'm standing here, is opposite over adjacent, so negative 15 over 8. And the cotangent then is going to be negative 8 over 15. So those would be your 6 trig functions based on this triangle, this line that goes through 8, -15. I guess it only asked me for those 3, so I actually didn't need those, but I could do them anyway. All right, let's do another one. I'm going to erase that, but that's going to need to be memorized, okay? Again, let's do sine, cosine, and tangent. When the terminal side passes through the point 3, 4. So I'm going to make my coordinate plane. I'm going to go over 3 and up 4. Okay, well, actually I'll just draw a line. Now remember, I told you you're going to drop a perpendicular line to your x-axis no matter where it is. All right, I know that I went over 3 and I went up 4. Your theta is always going to be right there at the origin. So the sine, oh actually first I have to figure out what that is. So I have 3 squared plus 4 squared, that's going to give me 9 plus 16. So that's going to be equal to my r squared. So 25 is equal to r squared, or r is equal to 5. So the sine of theta, I'm standing here, is opposite over adjacent, so 4 over 5. Cosine of theta is going to be adjacent over hypotenuse, or 3 over 5. Tangent of theta is going to be opposite over adjacent, or 4 over 3. Okay, all right, then sometimes they ask you to find the 6 trig functions based on the number of degrees they give you where the terminal side is. So let's say you have a 90-degree angle. Now it's going to be a little bit harder, almost impossible, to draw a triangle. So what I have is I have this. And it's going to go, like if I do just go up 1. So I'm always going to go over 1 and so forth when I don't have when I just have degrees. So let's say I've got 90 degrees. That's 0, 1 is that point up there. Okay, I go over 0 and up 1. So I know x is equal to 0, y is equal to 1, r is equal to the square root of this squared plus that squared, so r is equal to 1. Now I can do everything. Let's say they just want, I don't know if they want all of them, let's do all of them. The sine of 90 degrees is going to be y over r, which is 1 over 1, which is 1. The cosine at 90 degrees is going to be x over r, or 0. The tangent at 90 degrees is going to equal y over x, or 1 over 0, which is undefined. I can't have 0 on the bottom of my fraction. The cosecant at 90 degrees, I'm going to flip 1 over 1, so it's just going to be 1. The secant, now think about it, it's going to be 1 over 0, so this secant now is going to be undefined because this was like that, okay? Now the cotangent of 90 degrees is going to be 0 over 1, or 0. Now the bottom line is, guys, you can use your calculators to find this. Okay, this, at least these up here. Now this would be a little different, but just put in sine, put 90 degrees, cosine 90 degrees, and it should give you the answers. This is going to give you an error message, okay? So be aware of that. All right, the next thing we need to review here is special case triangles. And we're going to then turn around and put these on a coordinate plane. You have done special case triangles before, many times. 45, 45, that's x, and x on the square root of 2. Okay, for our purposes on the coordinate plane, we're always going to let x equal 1. Then I have a 30, 60, 90 triangle. The side opposite 30 is 1, or x. I guess I'll just do it that way. X on the square root of 3 and 2x. And again, we're going to let x equal 1 on our coordinate plane. So keeping that in mind, you might need to refresh your memory on that. We're going to go to the coordinate plane. Let's say I want to find the tangent of 300 degrees. Okay, one way to do it is you put it in your calculator. I want you to be able to do it both ways. So I just do tangent 300 degrees, hit enter. You need to make sure in the mode you are in degrees. Okay, the other way to do it is without the calculator. 300 degrees takes me all the way over to here. Okay, I'm 60 degrees short. I'm going to go ahead and drop a vertical line so I can do a triangle. And that gives me a 30, 60, 90 degree angle. Now remember, I said let x equal to 1. So the side opposite 30 is 1. The hypotenuse is 2 because it's x times 2, or 2x. This is going to be the square root of 3. So if they ask me for the tangent, I have to take into consideration that this is positive, my x is positive, and my y is negative because I'm going down to that. In the fourth quadrant, your x is positive, your y is negative. So I'm standing here at 60. I want to know the tangent, which is opposite over adjacent. So the tangent of 300 degrees, which is the same as the tangent of 60, is, down in the fourth quadrant, is negative square root of 3 over 1. Opposite over adjacent, or negative square root of 3. Now I think if you'll find that if you did that on your calculator, the tangent of 300 degrees, it's going to give you a decimal value that's going to be equal to that. All right, let's do one where you actually find, do it in radians. So let's say I want to know the sine of 3 pi over 4. Probably the first thing I would do is I would go ahead and convert the radians to degrees. So you should remember how to do that. Okay, I want to get rid of the radians. So pi radians is equal to 180 degrees. And that's going to give me a value of 135 degrees. Okay, so basically I'm asking for the sine of 135. You're going to learn later, like in pre-cal, how to do it without converting it. But here in Algebra 2, we're going to go ahead and convert it. Okay, if we're going to put it on a coordinate plane, 135 degrees is right there. So 90 plus 45 more. Okay, so that's 135 degrees, which means this right here is 45 degrees. Okay, now again, I can put that in my calculator and get an answer. If I do it by hand here, if that's 45, this is 45, this is 1, this is 1, and this would be 1 on the square root of 2. Okay, or just the square root of 2. So if I want to find the sine, and I'm standing right there because I'm going to be standing right there at the origin, okay, it's going to be 1 over the square root of 2. Okay, now let's take into consideration though what's this is negative. No, wait a minute, that's negative. Okay, so I don't need to have to worry about the negatives. Okay, so the sine is 1 over the square root of 2, but then I have to rationalize it, which is going to give me the square root of 2 over 2, which I think is approximately 1.7 something, which is what you're going to get there as well. Okay? All right. Let's try one more, and then we'll go on. Let's do the tangent of 240. Again, you can put it in your calculator, or let's say you're going to put it on a coordinate plane. 240 is 180 plus 60 more. So this would be 240. I'm going to drop my perpendicular line. This is going to be a 30, which means that's the opposite is -1 because that's x. This is going to be a negative square root of 3 because it's going to be x times the square root of 3. And then on your hypotenuse is going to be 2 because it's going to be 2 times x. All right, so when I do here, the sine, I'm standing, or the tangent, I'm standing right there. So the tangent of 240 is equal to opposite, which is negative square root of 3, over adjacent, which is -1. So it is the square root of 3. Okay? All right. Then there's a few trig identities that it would be helpful for us to know. These again are things that would be good to be memorized. Okay, I could just tell you that the tangent of theta is the same as the sine of theta over the cosine of theta. The cotangent of theta is the same as the cosine of theta over the sine. See how the C and the C go together? Okay. Also the cosecant of theta. I know that that's the inverse of the sine, so it's 1 over the sine of theta. The secant of theta is 1 over the cosine of theta. And the, let's see, did I not do, okay, and then the cotangent, this is another term for the cotangent, is 1 over the tangent of theta. Okay, so those are good things to know. We're going to actually use them in just a second. You can pause the video and write them down if you didn't get a chance. Let's say the sine is 3 over 5 and my cosine is -4 over 5. And I want to find these things: the tangent of theta, the cosecant of theta, the cotangent of theta, and the secant of theta. Now, it also tells me that the terminal side is in quadrant 2, which means my x is going to be negative and my y is going to be positive. Okay? Now, remember on your sine, you have y over r, and on your cosine, you have x over r. So I know that the x is going to be my -4. Okay, but based on what I just did, the identities, okay, probably this is the easier way to do it, is I say the tangent. Well, based on your identity, the tangent was the sine divided by the cosine. So remember, I have to invert and flip. So it becomes 3 over 5 times -5 over 4. So I'm going to get a -3/4. Okay? The cosecant is the inverse of my sine. So all I have to do is flip that. 5 over 3. The cotangent is the inverse of my tangent. So I'm going to flip it, and it's 4 over -3. When I say it's the inverse, understand that on this particular one, this is 1 over 3 over 5, which means 1 divided by 3/5, which means I'm going to flip it. And literally, if you put it underneath 1, what you do is you flip the fraction that's on the bottom. Okay, the secant is the inverse of your cosine. So I'm going to flip that, and I'm going to get -5/4. Very quickly, based on those identities that I just learned, I can do all those. All right, let's do one more based on this stuff, and then I'll give you the homework. Let's say my sine of theta is -2 over 2, and my cosine of theta is -2 over 2, and I know it's in the third quadrant, so my x's and my y's are both negative. I want to know tangent. The tangent of theta, I'm going to take the -2 over 2 divided by the -2 over 2. I'm going to invert and multiply, which is going to give me negative square root of 2 over 2.